imagine that you've got a bunch of code, written in many different languages, and you throw it all into an engine, and then it processes it. And then at the end of it, there is some analysis, quite sophisticated analysis done on the code. And then at the end, you get a nice representation of vulnerabilities found in your source code. So again, we're looking at the source code, we're analyzing it. The application is not up and running. We're just feeding the code into the engine, and we get the results at the end of the process. Now, dynamic application security testing, on the other hand, is a completely opposite kind of approach. So we don't know what's happening within the application. We're basically approaching it as a black box. We're trying to work on it or attack it from the outside to try and see whether it has any vulnerabilities. A lot of people would recognize this as penetration testing, basically same thing. Again, the approach to the application is purely black box, and it's completely from the outside and trying to understand what's going on inside the application by trying to break it. And then last is interactive application security testing. It's kind of in-between approach. So like with DAST, the application is up and running. But instead of trying and attacking it, we stimulate the application in more conventional, usual ways. The best way of doing it is by running a repetitive set of tests, preferably automated test suite against the application. And therefore, it can be done, or preferably to be done, in a testing environment. And then there is an agent sitting inside the application, listening to various layers of APIs. And then when a potentially vulnerable flow is detected, it gets reported in real time, and you get your findings on a dashboard. So in a way, it's kind of in-between approach between SAST and DAST, because the application is up and running. But we do have an agent sitting inside the application, so it's not fully black box. And we're not deliberately trying to break the application, but rather leveraging an existing testing suite and get security testing results, more or less as a byproduct of the regular testing process. So this is kind of a quick comparison between the different techniques. I'm not going to drill into each and every one of these. I just wanted to highlight a few really important points. So in terms of advantages of SAST, there are many. Probably the most important ones are the fact that you can start scanning your code from the very first moment you started writing the code. The application may not be fully functional, may not be even runnable. You can already start scanning your application code, and obviously, as you progress and as you create more and more components of the application, you can add them into the mix and get a better picture in terms of understanding of the vulnerabilities. Now, also because the analysis is done on the source code, it's also easy to understand what's wrong there, and it's also easy to understand how to fix potential vulnerabilities. It's also a relatively fast process. If you think about how long the entire process takes, so for a typical penetration testing engagement on a sizable application, it can take hours, days, maybe even weeks. With SAST, even if we're talking about relatively large applications of millions or tens of millions of lines of code, typical scanning time could be within hours. And if it's a smaller component, then you get your results within minutes. So these are the main advantages, and obviously because of all these characteristics, it's also easy to embed SAST into your CI continuous integration process. And we'll see a little bit later how this is done. Now, in terms of disadvantages, also because the analysis is done on the source code, there are some things that are difficult to see or predict. We don't see the data, for example, and in many cases, data is important. So some of the vulnerabilities that depend on the data are difficult to identify. Also, there are some assumptions made, and there are some assumptions made on how the different bits and pieces communicate with each other, and these assumptions may be wrong or maybe not fully representative of what's happening in the real environment, and therefore this approach is a bit more prone to what we call false positives. So that's for the disadvantages of SAST. Now, DAST, again, it's a completely different opposite approach to SAST. There are some advantages to DAST. Probably the biggest one is the fact that when you break the application, you know about this. It's easy to provide a tangible confirmation of the vulnerability. And another big advantage is that it doesn't require access to the source code, so it can be quite easily outsourced without providing the source code to the party which does the analysis. But there are lots of disadvantages, and some of them are implied from what I described previously. Obviously, it does require a functional application, which means that you can only start doing this relatively late in the cycle. It can only detect what we call reflected vulnerabilities, which means that the vulnerability needs to manifest itself. So for example, if there is a vulnerability which happens at the backend, for example, if you have some sensitive information written into the logs, and these logs are not accessible by the tester, you can't even find that this is happening. So not all kinds of vulnerabilities can be detected this way. But probably the biggest disadvantage is that it's really cumbersome and difficult to integrate DAST into the CI process, simply because of the sheer duration of the process, of the amount of work involved here. Okay, so that's why DAST is considered as a technique which is kind of problematic to embed into the CI/CD process. And lastly, regarding IAST, so some advantages here is that it does provide you with immediate feedback. So when a vulnerability is found, you can immediately get a notification that it's found. It also doesn't require access to the source code, and it can be integrated into the CI process. And again, we'll talk a little bit later about how this can be done. But it's obviously also quite cumbersome to embed. It does require a functional application. Probably the biggest problem with IAST as an approach is that its results actually depend on the comprehensiveness and coverage of the test suite. So if you have a really comprehensive and exhaustive test suite for your application, then IAST could produce good results. But if your test suite is relatively thin, if it doesn't cover all of the important areas of the application, then you cannot really trust IAST to provide you with much coverage. And this understanding is something that is not easy to come by. Okay, CI. What is CI? So basically, continuous integration. It's a process of integrating code into the mainline code base, and it relies on lots and lots of tools that streamline this process. And continuous delivery is the development practice basically based on CI. Now, if we look at the different stages of the CI/CD process, and we try to break them down into smaller bits and pieces, so what we're looking at now is the basic so-called short loop of the CI/CD, which is when you develop a piece of code, you build it, and you test it immediately as a part of the continuous integration process. So this is typically done in one go, in one automated or almost automated process. So you have a developer coding, and then committing the code, and then you have the CI environment where the environment is built, and you have some automated CI tests such as unit tests. And then when you also have an intermediate deployment environment, you can also deploy it and run a set of functional tests on top of it. So what you can do in terms of application security during this process. So first of all, when the developer is coding, you obviously can and should take care of training your developers about application security. This is really crucial, and educating your developers is something that needs to be done. This is one of the key ingredients of having your application secured from ground up. You can also do static analysis using IDE plugins. So basically, when your developers develop, they can run some application security tests from within the IDE using the provided IDE plugins. And they can also utilize on-demand advice if the vendor provides with this service. Now, during the build process, this is where most of the automation happens in terms of the application security. So you can do your weekly, daily static analysis. You can also utilize incremental static analysis capabilities if the tool provides them with. And you can also do the software composition analysis, which is understanding of the possible vulnerabilities that open source components or third-party components that your software utilizes might be using. And during the test phase, you can do dynamic and continuous testing, and you can do some application security testing there as well. And this is how the technologies that I've been talking about before map into these different places. So you can use SAST during the development of the build phases, and you can use IAST during the build phase. Now, if we're looking at the longer cycle where you also have deployment into a UAT environment and then potentially into production, this is where it probably would be the most appropriate to do your DAST, dynamic application security testing, but this is kind of already outside of the continuous integration cycle. Now, here is an important aspect of baking application security into DevOps. The earlier you do it, the more you get out of it. So basically, you really need to be thinking of integrating your application security as early into your development process as possible, so-called shift left. And you probably have already heard this shift left in the past. And why is that? Well, obviously we all know this picture. The cost of fixing an issue is way, way higher when you go further to the right into deploy and production stages. So this is kind of a depiction of how much it costs to fix an issue when your system goes into production. Now, all this creates this kind of uneasy situation where you need to balance between the speed of development, which is what the developers care about, and the security that your application security people care about. And we obviously do want for these two guys to exist in harmony rather than fighting. Now, let's talk a little bit about breaking the build. So we know that breaking the build is a sensitive issue. What we really don't want to happen is for the security to be the build breaker. We know that if you have many developers, if just one of them does something wrong and breaks the build, it creates a continuous problem. So we want to avoid all these kind of situations. Why is the clash? So obviously, on one hand, you have the speed requirements. So you want your build not to be delayed. And if you have your security scanning as a part of the build and you do full scans, this might delay builds. And also you need to introduce some work, introduce and maintain the security, application security steps, which are the part of your build. So this is on one hand, and on the other hand, you also don't want the security checks to break builds, not for the good reasons, for things like false positives or errors in configuration and stuff like that. So obviously accuracy is the key. So if we try to summarize this and we really try to chase down to the right kind of recipes of how this needs to be done correctly, we know that DevOps is about automation, as least friction as possible, as much agility as possible. So therefore, when you choose tools, solutions for DevOps, you really don't want to change whatever you have already. So your application security tools need to be able to play nicely with what you have right now. Another thing is you really need to understand that not all vulnerabilities should be eliminated from day one. So yes, when you introduce application security testing, application security scanning, there will be findings, there will be probably some false positives, but many true positives as well. And you need to accept these as risk and start prioritizing and start building plans how to eliminate this. But obviously, this cannot stop all other work from being done. Now, in terms of prioritization, it's also very important to focus on stuff which is really high risk. So for that, you can use presets that basically highlight only the stuff which is high severity, high priority, and deal with the rest of it later. So obviously, employing policies that highlight these high risk areas, high risk vulnerabilities is something that you can utilize first. And then as your maturity improves, you can start going into more advanced or less severe vulnerabilities which are still there. Now, open source vulnerabilities are really important to take care of. Why is that? It's because these vulnerabilities is something that everyone knows about, not just you. So once your software consumes a component which has known vulnerabilities, you can pretty much assume that the entire world knows about it. And fixing it should really be a priority. And maybe last but not least, you need to train your developers, but you also need to realize that they will not become security experts. So again, you need to embrace a policy that fits your DevOps flow and shift security left and right using the right techniques, and remember about open source. So that's about it. There are some resources here that I've also put these links into the chat, so you're really encouraged to check out these resources. There are some ebooks here, some webinars here that I would like to encourage you guys to listen to. Any questions?
I'll just take a look at the chat to see if there are any questions that have come through.
Okay, I have a question,
Sure.
Michael. On one of your slides, you mentioned about static analysis tools. So do you have any recommendation?
Well, I work for Checkmarx, which is a company, which is a vendor in this space. And obviously we have an extensive portfolio of tools and products in this area. One of them is static application security testing product. It provides very comprehensive, award-winning analysis. We're actually Gartner recognized leader in this space. And you're more than welcome to reach out to us and learn more about our products in this space.
Cool. Yep. Yeah, that was a cool overview. That was really nice. Yeah, thank you for that.
Okay, thank you.
Any more questions? Okay, we have a question in the chat. What SAST softwares would you suggest that can be easily integrated to existing CI/CD pipelines?
Yeah, so thanks for this question. So as I mentioned previously, I represent Checkmarx, which is a vendor in this space, and our products are really easy to integrate into the CI/CD space. I'll also put a link to our Confluence page in this chat, so you can go and check out some more technical documentation about how you can embed Checkmarx software into your CI/CD cycle. We provide lots and lots of different plugins, native plugins for different environments, like IDEs, CI tools, code collaboration platforms such as GitHub, GitLab, Azure DevOps. We have plugins for Jenkins, Bamboo. We have plugins for defect tracking systems such as Jira. So obviously, as I mentioned previously, being able to integrate into the existing tool chain is a crucial part of embedding security into DevOps, and we feel like we provide the right tool set for this. I'll put the link in the chat.